All right. So what's up, everybody? How's it going? How's it going?
Okay, me and Masha, we understand like chapter 10, and we've been studying, like we were studying yesterday together and we were studying today in the morning. We woke up early to study. But we have test anxiety. So like we're gonna prove to you right now that we know how to do it, but the tests are literally like what brings us
Understands
that. Yeah.
every time we study for like 4 days, 5 days, like the week before the test, and then when it comes to the test, both of us just like
And
vomit.
our notes, like my notes are insane. Like so
Okay.
much.
Cool. Okay.
We were
And
trying
as far as the test anxieties, all I would say is, hey, you're gonna like decrease your test anxieties right now by studying with me, because the more that you study, the less test anxieties you'll have, the more confident you'll be. So
Yeah.
right now, because you're doing this right now, watch, you'll have less test anxieties on the test, just a little bit, right? So you'll have
Oh,
every question you do, the more times you do it, your test anxiety should go down a little bit each time.
Yeah.
Because like when you look at a question and you're like, oh shoot, I don't know what to do. Yeah, that's gonna bring you test anxieties. But if you look at a question and you're quicker, you're like, oh, I already know what to do, then that's gonna help the test anxieties go away. You know?
Yeah.
So you're doing good. All right, so let's check this out. So this question right here, right?
yeah.
Let me pull
Like
it
I
in.
get how to find the p-value for all the other ones. Like normally my p-value is right, but then for this one and like the next couple ones, it come out wrong. And we don't know why. We can't figure out why. Wait, and Simo, so how
Yeah.
me and Kim have been doing it for the upper, like let's say it's let's say it would be like right-tailed. For the upper, we would put the t-score or the z-score, and then we'd put the 999,
Yeah.
and then we would do 0, 1. Is that okay? Like for the work, like we wouldn't do the whole equation you said, and our answers would come out.
For this question, no, that's not right, because you can't use NormCDF for the mean. Notice that this question is dealing with the mean. So if you put in 0, 1, then you are doing it wrong, because you're using a normal distribution. You can't use a normal distribution with the mean. You have to use a t distribution, okay? So if you were doing that on this specific question, then you're doing it wrong, because that means you may be using NormCDF. I don't know. Were you using NormCDF on questions like this?
Yeah.
Then you're using the wrong distribution. We're not in a z distribution or normal distribution, I would say. We got to use tcdf, and that's a t distribution.
Oh my god.
So that's it. That's all you needed to know.
But what is like, how did you identify like the difference? Because some of the other ones we would use NormCDF from you and it would work. Like how did you just determine?
So the NormCDF, you'll use that in chapter 8 if you know sigma. And that's only, I'm telling you right now, that's only going to be in chapter 8. In chapter 9 and 10,
literally we did all the homework using NormCDF, and it worked. Like not even gonna lie, it worked.
It works?
Yeah, we've been using like 0 and 1 for the
like we wouldn't end, like we were going through your notes, and then we were looking at like the equation, like the square root one, but we stopped using it because we got stuck on a problem, and then my brother just said use 0, 1, and then it worked for all of them. Like it would literally work for all of them except for this section.
So let's try this one. Let's try this one. You guys are good with finding the test statistic, right? You're good with finding this?
Yeah.
So you know that. Okay, so now I want to show you guys how to find the p-value now. Now remember, this is a t-value, so that's a t distribution, right? So you have to use the t distribution, tcdf. So all you do, let's see, this is a left-tailed test. It says less than 9.02. So all you got to do is, let's see, for finding the p-value, you can draw a picture like this, put 0 in the middle, because like you said, you got to use 0 and 1. You're right on that. And then just put negative 3.99 here, because that's your test statistic. So it's a left-tailed test. So you're going to do this. You're going to say that the p-value equals to tcdf of what? Negative 9999, comma, negative 3.99, comma, degrees of freedom. Now the degrees of freedom would be n minus 1. The degrees of freedom equals n minus 1. So what was n? Anybody know the sample size? You can find that easily, right?
Yeah.
The researchers randomly selected 10 adolescents. It looks like n is 10. So then my degrees of freedom is going to be 9. See? And that's all you do to find the p-value. Let's do that.
Okay. But let me see.
And you
Wait.
should get, and if you do that, you should get 0.002, right? So let's see if we get 0.002.
It is right. It's 0.002.
You don't want me to show you in the calculator or no?
I got it. I did it on my calculator too.
So second distribution, tcdf, negative 99, you already got it right, so that's good. And then negative 3.99, comma, what, 9. So look, 0.00, let's see if we got their answer. 0.002 if you round it, right? 0.002. So there you go. Now guess what happened to your test anxiety just now? It went down. It went down because you just learned something new. Now when you get this on the test, you're gonna know exactly what to do. Do you see that?
Yeah.
Yeah.
Okay, so I don't know if I should send it to you, but like I just went back one question to number 4.
Yeah.
And we had done it the other way. You want me to send it to you so you could just see?
Sure.
No, I got that one. Could we just do one where it's a two-tailed test? Because I was really confused.
All right, sure.
I have a two-tailed one I could send you if you need it.
Whatever you guys want to do next. Jack wants to do a two-tailed test. We'll do a two-tailed test.
Okay, I'm gonna send you a two-tailed one. I think it's number 10 that's two-tailed. Yeah, it's the one where it's equal to and then non-equal to. That's two-tailed, right? Yeah.
Yeah.
I had a question. How would you, for some of these questions, it would like right here, it says sufficient evidence. How do you determine if it's sufficient or insufficient?
For this question right here?
Yeah, for instance, for this one, you could do it for that one too.
Sure. All right, let's talk about that. So you're talking about the conclusion. Now, what I'm going to be looking for in the conclusion is to say this part will be like part 1, but they didn't say why. I want you to do that and say why. And then this is the second step where it says there is this, so whatever this. So this is like step 2, okay? Remember how I told you there's a technical and non-technical conclusion? That's kind of what I'm looking for. Are you guys good with saying why you reject the null? You're supposed to, do you know why?
So you would say reject HO or H subscript 0.
Yeah, you would say reject H sub 0, the null, and then you just say since, and you have to give the reasoning why. So why would you reject it, Kimberly?
P-value is, can you zoom out a little?
Yeah, we got the p-value up there, right?
Since p-value, what was the significance level?
Yeah, there's the significance level.
So
let me zoom in. Okay, so you're gonna say reject H naught since the p-value is what?
Less than 0.01?
Less than 0.01. Good. There you go. Now, let's go with Maria. Maria wants to know, how do you do the next step? After you reject the null, you want to say what to do then. So I'll give you a thing, Maria. When you reject the null, just say there's sufficient evidence.
Oh, so every time it's reject. Oh, that makes sense. Yeah, that's true.
There's sufficient evidence to conclude the alternative. That
So
makes sense?
basically, once you decide if you reject it or not reject it, then you could see if it's sufficient or non-sufficient.
Right.
Okay.
Yeah, if you reject the null, there's sufficient evidence to conclude the alternative, right?
Mhm.
If you fail to reject the null, then there's not sufficient evidence to conclude the alternative. So right here, so look, what am I doing? I'm rejecting the null, right?
Mhm.
That's why it says there is
Sufficient.
sufficient evidence. To do what? And I hate the word claim. I would say conclude. There's sufficient evidence to conclude that the mean is less than, guess what that was? That's H1, right?
Mhm.
That's the alternative. This last part of the conclusion is always about the alternative hypothesis. There's either sufficient evidence to conclude it or insufficient evidence to conclude it. So if you reject the null, there is sufficient evidence to conclude the alternative. All right, so that answers that question. Now, did you want me to do Jack's question now?
Yeah.
Yeah, 9. It's 2.
Okay, what do you want me to do with this one? What do you want me to focus on, Jack? Just finding the p-value?
Yeah.
Okay.
That's kind of the main
Can
part.
you low-key find the test statistic too? Because me and Kim were stuck on that one. That's why I didn't finish it.
Oh, for sure.
Yeah, I've had some weird ones with the test statistic where it's like I'll just get it wrong, but like
Yeah, like you'll do what it.
putting in the numbers in the calculator just keeps getting, it gets like a way different number somehow.
Did you ever figure out why? If not, you got to email me and be like, hey, I'm getting this wrong. What's up? How come I'm getting this wrong? All right, so this is for Jack. So it says, let's go with Kimberly.
A golf association requires that golf balls have a diameter that is 1.68 inches. To determine if golf balls conform to the standard, a random sample of golf balls was selected. Their diameters are shown in the accompanying data table. Do the golf balls conform to the standard? Use the alpha equals 0.05 level of significance.
All right, cool. Conform to the standards. What's the standard? The standard is that the golf balls have a diameter that is 1.68. I guess that's the standard. They need to have that diameter. So that's why we say that the null hypothesis is that the mean is 1.68 because that's the standard. The golf balls are supposed to be that width. And the alternative is a two-tailed test. Why is it a two-tailed test? Because the golf balls, we don't want them to be too big or too small, right? So it just says determine if golf balls conform to the standard. So what does that mean, conform to the standard? That's not a directional alternative hypothesis, right? It's a two-tailed one.
So that's kind of like the key word to let you know that it's two-tailed.
Yeah, this one's got a little bit hard, like conform to standards. You're looking for keywords like greater than or less than or different from.
Yeah.
There are no words in this question, but you still got to do your best.
For the test, are you using questions from MATLAB or are you creating them?
I don't know. I'm not sure yet. I'll create some and use some homework questions.
You haven't made it. The test is on Monday.
I usually make the test the night before or the morning of.
You're lying.
I'm not. You guys are going to get an A on this test, hopefully.
Yeah, I hope. I really hope.
You gotta, just have confidence. And
You're
have
still
confidence.
One of the tests, correct?
Yeah, I dropped the lowest test score.
Yay.
Just have confidence and also just try your best. And if you do bad, that's okay.
That's not okay.
I know. It's not, it's not. But think this, like, all you can do is try your hardest. That's what I'm saying.
Yeah.
You just give it your best shot and hope to pass. That's it. And if you don't pass, that's out of your hands because all you can do is try your hardest.
You say this test is the hardest, so it's like, if I didn't even do that good on the last ones and I studied so much, oh my God. I don't even want to see what's going to happen with this one.
You're going to do well. Be confident. All right, so look, one thing to realize is that we are talking about the mean. So we're definitely got to ask ourselves, do we know sigma, the population standard deviation, or we don't know sigma, the population standard deviation? I'm telling you now that in chapter 8 and 9, you're never given the population standard deviation because you can kind of assume that it's a t distribution. Although in real life, you read the question and figure out what you have. It seems like we have data. There's no data here.
No, there is.
Given.
Click the table.
Oh no, yeah, you have to click the little.
You
click that. You got to click that to get the data. So let me go back. Hold on. So watch. If I click this, there's the data. Now, if you want to find the mean and standard deviation of this, I recommend just clicking StatCrunch so you don't have to waste your time plugging it into your calculator. Although for a test, you should waste your time plugging it into a calculator because you guys are going to be using your calculator on the test.
Yeah.
But for right now, we can kind of optimize it and just click that box, right? To get the mean and the standard deviation.
So
but on for you guys practicing, definitely use your calculator and like plug it all in, right?
Yeah, I use my calculator.
No, I got it, but for this one, my X bar came out to be the same as my, what is
the
that?
hypothesized mean, 1.68?
Yeah, I got 1.681 for X bar.
Okay, let me see if I can sign in here. So if I click this box, open in StatCrunch, I'm gonna hit stat, calculators, no, summary statistics, columns, just click, oh, there it is, diameters. Okay, and then just press compute. And then, okay, so what do we get for our mean and standard deviation?
1.68 for the mean.
So you can have StatCrunch give you whatever you want. It's giving us a lot of stuff, like all of the summary statistics, kind of like a calculator. So let's see what we got. All right, what we wanted was 1.681, which that's the same thing that you got, Maria, right?
Yeah.
And then standard deviation, did you get this? For S?
0.04. Yeah, for S.
0.0045, right?
5, yeah.
So this is going to be our S and this is going to be our X bar, right?
Yeah.
You did that right. So then good. All right. So moving on. What we're going to do now is find the test statistic. The way you find the test statistic is T sub 0 equals to X bar minus mu divided by S over square root of N, right?
Yeah.
Okay.
I did that, but my answer was at first I got 0 and then I got 0.69 right there, but both of them were wrong.
Okay, so look, 1.68, that's the mean from there. And then X bar is there. So then, okay, keep on going. So S is 0.004533. Maybe leave a lot of precision here.
Maybe I rounded it too early.
Yeah, you gotta be very precise if you want to get the answer from the computer, because the computer is very precise, right? So square root of N, what's N? N is given here to be 12. See how it gives us the sample size?
Yeah.
So 12. Okay, there you go.
Oh, I think that was my mistake.
What, did you round this too much?
I rounded to 0.006.
Oof.
You get me? Like,
Yeah, 0.006. Yeah, that'll do it. That'll do it.
that will mess it up.
Oh, heck yeah.
Then how do you like, because usually the standard deviations they give us, they're rounded to like only 2 decimal, like to the thousands place, or like maybe like to 4 decimals, but like never that much. You know?
If you want, you could round this to 4 decimal places. You can say 0.0045. That would be okay. Or maybe it's even 0.005 might be even okay. It would probably give you the right answer if you rounded it to 0.005. Now, I wouldn't risk it. I would give like a lot of digits there. But these should be okay if you round to those, right? But watch. Oops. 1.681 minus 1.68. Enter. That's weird. Divided by, and I'm going to put divided by 0.005. Watch. I'm going to round a lot and see if it gives us the right answer. Divided by square root of 12. It's giving me 0.6928, and the answer is supposed to be 0.69. So it's correct, even though I rounded.
The answer isn't 0.69. That I got it wrong when I did 0.69.
Okay, then let's go to the answer real quick. Let's check the answer.
I think I couldn't check, but I think it's Yeah, it's 0.76. It's just 0.76. So you rounding didn't I did it the way you did it right now.
Yeah.
And I didn't round the standard deviation, and the answer was 0.76.
So that's a lesson to us all, isn't it? Isn't that a lesson to us all? Like not to round? Because look, so you're telling me if I round to this, I'm getting the wrong answer, right?
Yeah.
What about this one? Can I round to that? What about that? Let's try that one. 1.681 minus 1.68. Let's do experiments. We're doing experiments here. I'm going to do 0.0045, and I'm going to divide by square root of 12. Okay, I'm going to round like that. What are we looking for? 0.76, right?
Yeah.
Let's see if this works. It didn't work. It gave 0.77. Even this doesn't work.
Yeah, I just got 0.7.
See, isn't that like kind of how are you supposed, like, it doesn't even say which number to round to get the answer. So how would you, like, what if you put the whole number that the SX was equal to? Your answer would be round 2. So it's kind of like...
No, it would be correct. No, it'd be correct because it's more accurate.
Yeah? If you do the whole number?
Yeah, if I put this whole number, then it's the most accurate you can be. What? 0.045327094. Then that's going to be the best thing I can do. Watch. 7.6. See? But the more I round, the worse my answer gets. So what's the best thing to do? Just keep everything. The more accurate. Why not be as most accurate as you can be? But as we saw, I mean, we needed to have what? What did we need? We needed like this much accuracy, right? Oops. We needed to go to like the 3 there. So not 4 digits, but we needed 5 digits in order to get their answer. So, which is crazy. It is kind of weird, yeah, but it's weird, but I understand why it is, right? Because we got to be more accurate.
I just thought I was doing
a toast to accuracy. A toast to accuracy.
I make the best iced coffee, guys. If you need the recipe, let me know.
Hey.
So then, how do you find the p-value? You do tcdf?
All right, back to Jack's question. How do you find the p-value? And now Kimberly. So look, we have that this is equal to approximately 0.76?
Yeah.
Or even to be more accurate than that, it's 7642, right?
Yeah.
So I don't know. You can use 76 or 7642.
You could use 0.76.
You can probably use 0.76 too.
Because it's already in there, so I feel like they're just gonna go off base that.
But I wouldn't. I mean, of course, on the test, you're not doing that. Yeah. On the test, you're just gonna leave like to the 4 digits and then use those 4 digits when you do the p-value. All right, look, p-value time. Mm-hmm. What's that?
On the test, you also mentioned how many decimal points you want us to round it to usually.
I probably won't. Maybe. I'm not sure. I should. All right, look. So here we go. To find the p-value for a two-tail test, this is how you do it. You do this, draw your little mountain. In the middle, we're gonna put 0 now because we're doing a test statistic, a standardized score. So the mean is 0. This is t sub 0. It's a standard. That's a z-score or t-score. So it has a mean of 0 and standard deviation 1. So here's the key. Our test statistic is 0.76. I'm gonna put it over here. 0.7642. I don't care what's on the left. I know that there's something on the left too. Whatever it is down here, it's question mark. We don't need it. The reason we don't need it is because the p-value we can just multiply times 2. I care about just having at least one of the values, like this one, because then I just find this area and I multiply it times 2. It's because of symmetry here. There's symmetry. This and this are equal. They're equal, so I can just find 1 and multiply by 2. So in light of that, to find the p-value, this is how I'll do it. p-value equals to 2 times what? tcdf
Okay, no.
0.7642 comma 9999 comma degrees of freedom, which what was the sample size? Do we know it? Yeah, it's 12. So degrees of freedom is 11. So I can just put 11 here and that's it. There you go, Jack. That's how you find the p-value.
Okay. And then you just do the same thing even if you got negative.
Right. Right.
Statistic.
Yeah, if I got this side, like a negative over here, my test statistic was negative, and I had this value and not that value,
You
just do the same thing.
But just minus 999.
Yeah.
Okay.
Yeah.
Okay, that makes sense.
And then just multiply times 2, yeah. There you go, that's it.
Okay.
That's how you find the p-value. Got to get the 2 in there, so 2 times second distribution, tcdf 0.7642 comma 9999 comma 11. Enter, and you get a p-value that equals to approximately 0.4608. There's your p-value.
So this one we would reject, no?
Correct.
Yeah.
Yeah, because the p-value is high, so the null will fly. Did you say that we would reject
Yeah.
or fail to reject?
Fail to reject them.
Yeah, fail to reject, right. The p-value is high, so the null will fly. So then since we fail to reject, what does that mean? Do we have sufficient or insufficient evidence to conclude the alternative?
Insufficient.
Yeah.
Right.
I
So you,
learned.
what?
I learned
How do you feel?
a lot better because I was confused on that. I didn't know like when to determine whether it was sufficient or insufficient.
There you go. So your test anxiety went down.
Yeah, you're gonna catch me on the proctorial recording talking to myself, saying if the null is high, if the p-value is high, the null will fly.
Nice.
She got that stuck in my head.
Good. That'd be cool.
I
Maria,
did. I kept saying it, and it got stuck in her head.
You what?
I kept saying it, like I was talking to myself as we were studying, and it got stuck into her head, and now she says it too.
Nice.
Like, and I would be like, wait, Kim, what am I? Am I flying? Am I falling? Like,
Maria, where are you at? You texting? We can't see you anymore.
I'm here.
No, but your camera's gone.
Oh, I think I accidentally pressed
The world wants to see you, Maria.
the world. I know they do. But I'm anti-social.
Anti-political. No, I'm just kidding.
I am taking politics.
You're taking poli-sci? Okay.
Yeah.
All right. Is there any other questions you want me to do?
Could we just go over some of the ones from 10.5 where you have to choose which
Okay.
you have to figure out which test statistic to use?
All right.
D or T.
Okay, let's do it. I like your glasses, Maria.
Thank you.
Are those prescription?
I'm kind of blind.
Oh, Masha and I wanted to do number 11 on 10.3. I'm gonna send it.
Okay, send it.
Oh, yeah.
That one was so long. Oh my gosh.
And the yes and no's on that one,
Yeah.
oh my god, the final checks literally
That one was
gave me
pissing me off.
anxiety. Like,
Oh man, let's do
really
it.
getting me so bad.
Let's do it.
It's like when there's one final check, it's just like brings out your anxiety. Like, is it yes or no? And then you know the right answer, but then you still click the wrong one. Like, literally what me and Kim would keep doing.
All right, about this question, you guys, which part do you want me to focus on? What letter?
For that one, basically, it would be tcdf, right? I think that's just what we were doing wrong. I'm pretty sure now that you corrected us.
Yeah.
tcdf, right? And it would
Yeah.
be 1.65 and then the 99999. And then what would go after the 9999?
The degrees of freedom, n-1.
And that 40, so 39? Okay.
Yeah.
So basically for all of 10.3, it's going to be tcdf.
Yeah, all of the mean questions. I told you, chapters 9 and 10 are half tcdf and half NormCDF. Any proportion questions are going to be NormCDF, and any mean questions are going to be tcdf. That's it.
Can you like circle where that is, like what to determine, so like I could see it?
Good question.
right?
Good question. So like,
Just-
so it says suppose the mean IQ score. Well, I already know to use tcdf.
And
'Cause
that's
it's-
also using the T test statistic instead of Z test statistic?
Yes.
Okay.
So for the mean, you have to use the T sub 0.
Mm-hmm.
As
So
the
that's
test
how you know how
statistic.
to define.
Yeah. Because it says suppose the mean, I already know it's a tcdf. It can't be NormCDF unless it's a chapter 8 question, which that's what I have to look for. How do I know it's what chapter it is? Complete parts. You don't know yet. Oh, you don't know anything actually. At this point, we don't know that it's a chapter 10 question. until you get to this where it says consider the hypothesis. Also, another thing that's interesting is this. It says, suppose the director of a college obtains a simple random sample of 40 students. Okay, so we know it's a sample and finds that the mean is that and the standard deviation is that. So that standard deviation, that's the big question. This data here, the standard deviation and the mean, they're actually from the sample. So they're S. And that's how we know to use tcdf, because the t distribution is when you don't know sigma, the population standard deviation.
tcdf for the mean, right?
Yes, and it's when you don't know sigma. And I'm telling you right now, in chapter 9 and 10, you'll never know sigma.
What?
Only in chapter 8 will you know sigma. Sigma is the population standard deviation.
Oh, yeah.
Is it because these questions are sample questions? Is that why you don't know the sigma? I don't get like why you don't.
Yeah, because it doesn't tell us. Let's read it again. It says, suppose the mean IQ score of people in a certain country is 101. So that's mu.
Mm-hmm.
That's the population mean, right? The mean IQ score of people in a certain country is 101. That's for everyone in the country. That's not a sample, right? Okay, so then it says, suppose the director of a college obtains a simple random sample. Okay, now we know that it's a sample. He obtains a simple random sample of 40 students, so that's N. 40 is N, right? From the country, and finds that the mean IQ is 105 and the standard deviation is 13.4. Those are the summary statistics. That's X bar and S, right?
Yeah.
Because it was from the 40 people. So you have to read the question and figure out what are all the numbers that you have. Are they the summary statistics or are they mu? Like the 101 right here, that's mu. That's the population mean.
Yeah.
But the 105.5 and the 13.4, those are the S and X bar.
Right.
Yep.
And then to find the p-value for this one, we would do tcdf 2 times tc. Wait, no, it's not 2 times because it's a right tail test. So we would
I don't know. Let's check it. It was it's a right tail test, so it's not 2 times. It would just be 1.
Yeah.
Every single time it's two-tailed, it's always 2 times, no matter if it's NormCDF or tcdf.
Correct.
Okay. 2 times.
And you guys feel more comfortable now?
Yeah. I just need to like study this more.
Yeah, now you just practice it. You guys have all the skills now.
Yeah.
Start doing the homework and see what happens.
Wait, and then when do we use inverse T again?
That's for chapter 9, confidence intervals.
Yeah. Okay.
Yeah.
That's what I thought is the other chapter. Is that's when you have like the area.
Right.
Oh,
Yeah, that's the area and degrees of freedom.
Yeah, I want to review that too because I kind of forgot that.
Okay. Send me a question.
Yeah. let me
I was gonna say for the test, are you gonna focus like more on chapter 10 or are you really just gonna break it down chapter by chapter and that's it?
I'm gonna break it down equally throughout all the sections. So yeah. Chapter 8 is sampling distribution, so some questions from there. Chapter 9, confidence intervals, so some questions from there. Chapter 10, hypothesis test, some questions from there. Equal distribution. All right, so this past year, an organization conducted a survey and asked, what do you think is the ideal number of children for a family to have? The results of the survey are shown in the table. Okay, check out the table real quick. So there's the table, it's grouped data. Interesting, grouped data. Wow, this is a fascinating question. I've never seen a question like this. What the heck, crazy. We're giving grouped data. Okay, so the mode is 2. Most people want to have 2 children. One person wants to have 11 children. Looks like it's a right skewed distribution, but that's interesting. Wow, this is very cool. How come I didn't know about this question? So what do you want to ask about this? What do you want to work on?
I mean, the main part I was getting wrong was actually further down. It was like for the standard deviation.
Like E down here, or?
Yeah, finding the standard deviation and then finding the finding like the p-value for it, just because it's all grouped.
Dang, what a question! Oh my gosh. Okay, for the mean and standard deviation, like part C, right?
Mm-hmm.
So
the mean you just had to go through and like get the probability for each one. So that was just kind of took a while to do, but just like a lot to write out to keep track.
To tell you the truth, if I was you, the way that I would do this question is this. In L1, I would put the numbers in the left column. In L2, I would put the frequencies. And then I would just do 1 bar stats, L1, comma, L2, and it would give you the mean and standard deviation.
For all of it?
Yeah, it would give you the mean and standard deviation.
Okay, yeah.
I put the L because this is the chapter.
Frequency in L2?
Yeah, frequency went in L1.
Frequencies go in frequency list if you have the wizard on. If you don't have the wizard on, put the frequencies in L2. So this is a chapter 3 question, actually. I've never seen a question like this in chapter 10. This is cool. I didn't know they had this. But to find the mean and standard deviation, just plug it into list 1 and list 2. Boom, it'll give you the mean and standard deviation. This is a good question for the final. Like, awesome question. Because it basically reviews something that we learned in the past, you see? And it's dealing with something we're learning right now. I love this question. But does that make sense, how to find the mean and standard deviation?
Mm-hmm.
Yeah, so that's all you do.
You just put the number in the first one and then the frequency in L2.
Yeah, and then you just do 1-bar stats, L1, comma, L2, and it gives you the answer. I've never done that on StatCrunch, but I usually do it on the calculator. I'm not sure how to do it on StatCrunch. That's it. That's how you do it. Were there other ones on this that you wanted help with?
No, I think that was kind of the hardest part of it, was just finding, like, going through it.
Cool. All right. Any other questions? Did you send me another email? Did you want me to do
Yeah.
that? All right. Now, what would you want help with on this one?
No, I got it when I was doing it. I just remember it being the one where you could choose, like when it was like when you're doing it, it asked either to use T or Z.
How come I don't see that on here though?
Because I think it's already just filled in with all the answers. Like when it was just a new question. I don't know if you can hit similar question.
Let's see. Okay, so determine the null. Okay, let's see. Null's always equal. This might be less than. I don't know. Just check it.
Greater.
Okay, just try greater than. Let's try greater than. Okay, and then let's see. Oh, so you're supposed to choose Z or T. Got it. All right. So a couple things. Number one, always choose T.
Always choose.
Because it's a hypothesis test, and you're never going to know the population standard deviation. Number one. Number two, if you have the population standard deviation, choose Z. If you don't have the population standard deviation, choose T.
So that's like the main thing in deciding is that you have the.
Yeah, if you have the population standard deviation. It says a simple random sample of size n equals 40 is drawn from a population. The sample mean is found to be 109.1. And the sample standard deviation, see that? Sample standard deviation is found to be 22.2. Is the population mean greater than 100? So notice that our mean and our standard deviation are the X bar and S, and that's why we do T distribution.
So if it said the population standard deviation, you would use NormCDF and Z.
Yeah.
Okay. Yeah. Okay, that makes sense.
Yeah, good job. Question.
And then on 10.5, number 5, I'm just a bit confused finding. I have the Z test statistic, but just getting the critical values then from that, I just can't.
That one. Yeah, we're not supposed to do that one.
Oh, okay.
Somehow it's in the homework. I can show you how to do it. It's kind of like confidence intervals because it's a critical value, but it's not supposed to be in their homework.
Okay, so we shouldn't need to worry about that, I guess.
Yeah, don't worry about that for the test, but that's for a different method because we do the p-value method, but you can also do the classical method or the traditional.
Now would you just use the tables for that?
No, don't use the tables. You would use inverse norm or inverse T to find the critical values, kind of like what you did in chapter 9. So if you want, I can show you that as it'll help you review for chapter 9.
Yeah, sure then.
Critical value. What does critical value mean? I'm going to show you that right now. That's a chapter 9 term. They used to have a party right here, like right next door. That every Saturday night at like 6 or 7, a DJ would play music loud. This is like a month ago. Every Saturday night, there would be like a DJ out there, like they'd be like, "Hey, what up?" And he'd be on the mic talking to everybody. People would be on their balconies all around here, and it was crazy. It was fun. I wish they still did it, but maybe they're starting up again. What?
You live in Santa Monica?
Yeah, West LA.
That's far. I live in Hollywood.
Nice. Hollywood.
H-Wood.
Is it H? It's H-Wood?
Yeah, Hollywood, H-Wood.
H-Wood?
Don't even start.
Don't even start it. Don't start it.
You don't want to see what you don't.
Yeah, I don't want to do it. I don't want to bring that upon myself.
Too many memories. Right, Kim?
Yeah.
Is that from like high school? You guys used to do it or what?
Yeah.
Okay.
We were on cheer, so.
Okay.
Had a lot of loud vocals.
Got it.
Okay. That's why we're really social, because we were conditioned to be social.
Got it.
We came in antisocial though. We came in from the same middle school, like not liking anybody. Then we were forced to just talk to everyone because of
Yeah.
Got it.
literally like the administration. No matter who it was, we had to talk to everybody.
That's good, because it's good to be social. You need to be social.
Yeah.
You want to, it's important. All right, so where are we? Okay, so check this out, y'all. It's asking for critical values, so that's not the p-value method. Sorry, this is in the homework. It shouldn't be, but the critical values are. Now, for a two-tailed test, I didn't teach you guys this. Don't worry too much. Actually, don't worry about this at all. But it's a little bit related to chapter 9. That's the only reason I'm teaching it to you real quick. But I'm not going to be asking for critical values on the test for chapter 10 because we do the p-value method. But it's interesting. I've never seen these questions because they're not supposed to be here. But look, this is interesting that there's 2 critical values because it's a two-tailed test. And this one, the critical value is singular, one-tailed, right? Do you see that? That's super cool. If that's one-tailed versus two-tailed, now look at this. It's one-tailed, so there's only one critical value. So the way you find the critical value, it's based off of the significance level, which is 0.05. So you got 0.5 in the middle. It's right-tailed. So this area here is 0.05. So all I got to do to find this value right here, I'm going to call this the critical value. What should I call it? Let's say that it's z sub 0. And we'll say that it's inverse norm, curveball. I'm using z. Why am I using z? Think about that. But inverse norm, I'm going to put 0.95, dun, 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 because it's the area to the left. So that is how you find the critical value. So that should be like 1.96, I'm thinking. See, do they have an answer? 1.645 was wrong. It's the other one. It's 1.645. If you plug that in, you'll get 1.645. So do you see how the critical value is simply chapter 9, confidence intervals? We did this a lot where we had to find the critical values. It's really the same thing as chapter 9, critical values. Remember, in chapter 9, we use the inverse norm for confidence intervals, right?
Yeah.
So does that make sense? How I found that z-naught? Technically, this should be a 0 here because we're doing a z-score. So technically, that should be a 0. That's how you do that, Jack.
Okay. How do you get the 0.95 again?
Okay,
Just
0.95, the area, this area here, this area in here is 0.95, right?
Mm-hmm.
Because the area to the right is 0.05, therefore the area to the left has to be 0.9.
Has to be, yeah.
Yeah, okay, add the 1.
Wait, I'm just confused where the 95 or the 0.05 came from.
0.05 came from the confidence level.
Oh, okay. The level of significance, or
yeah, where did it go? Oh yeah, level of significance.
So if it was like 0.01,
If it's 0.01, then this would be 0.01, right?
Yeah, it would be 99%, I guess.
Yeah, and then this would be 0.99, right?
Okay, and then you just do inverse norm with that.
Yeah.
99, or
yeah, then I would just put 0.99, yeah.
And for inverse norm, you don't need to do anything for the mean or standard deviation.
Correct. It's 0 and 1.
Yeah.
It's automatically 0 and 1 by default.
Okay.
Yep, that's it. This is confidence intervals. All right, check it. Let's read it. In a survey of 1,016 adults, a polling agency asks, when you retire, do you think you will have enough money to live comfortably or not? Of the 1,016 surveyed, 535 stated that they were worried about having enough money to live comfortably in retirement. This is a good question. Construct a 99% confidence interval for the proportion of adults who are worried about having enough money to live comfortably in retirement. Okay? So did you catch that? Construct a 99% confidence interval. So that's what we're trying to do, a 99% confidence interval. For what? P or mu? Probably P, I'm thinking. Is it a proportion or is it the mean? It probably says it for the, see that? Proportion. So you got to look for a certain thing like that. Also, we got some numbers in here. There were 1,016 surveyed.
That's our
That
N.
looks like N, and there are 535. That looks like X. So it looks like now that would be P hat.
Mm-hmm.
So P hat equals 535 over what? 1,016.
Wait,
okay, that's our P hat.
All of this, do we have to check any conditions for the extra credit for this?
Yeah, you have to check the conditions, but that's extra credit. You check number 1 that it's a simple random sample. 2, you check that N times A. This is confidence interval, so N times P hat, 1 minus P hat is supposed to be greater than 10. And then 3, you check that 20N is less than or equal to capital N. So you just check those 3 things if you want to check the conditions. This is confidence intervals. Note that this is kind of interesting that we're using p hat.
Yeah.
Because we don't know p naughts, p sub 0, we don't know that. The population proportion. This is confidence intervals. So yeah, those are your conditions. And then that's your p hat, and that's it. So then to construct the confidence interval, what we're gonna do is the hardest thing, just think of this. Let me give you a couple formulas. First of all, the confidence interval formula is going to be p hat minus e, p hat plus e, right? So that's it. You already have p hat. Now e, what is e? It's the margin of error, and it's equal to, let's think, it's the proportion, so it's a normal distribution. So I'm going to do z star times square root p hat 1 minus p hat over what, n?
Yeah.
There's your margin of error. Now the hardest thing to find would be this z star, right?
So wouldn't we do 1 minus 0.99?
Yeah, exactly. You would draw a picture like this, and then you would say it's 99% confidence interval. So yeah, this middle area here is what, 0.99?
Yeah.
So then you would do that. 1 minus 0.99 is what? 0.01. Divide that by 2, you get what? 0.05 or 0.005. Be careful, that's 0.005. So we can call this value here z star and negative z star, right?
Mm-hmm.
In the middle, we have 0. So yeah, now you can find z star or negative z star, whichever one you want. You could even find z star if you want. But I think in class, we did find negative z star. I think negative z star is easier to find, and then just change it to positive, because negative z star is what?
Would we do inverse t?
I don't know. Inverse norm.
Oh yeah,
this is
inverse
p.
norm.
This is p.
Yeah,
Inverse norm.
And then we would do 0.005, and then
Correct.
we would do degree of freedom.
No, that's t. That's inverse t.
Oh.
Remember, inverse norm and inverse t work differently. Inverse norm, there's no degrees of freedom. That's only for the t distribution.
I confuse all of that.
Yeah, no, but that's good. You got to confuse it now. You got to confuse it. That's called, learning. When you confuse that and then you figure it out, boom, that's learning.
So z star, okay, inverse norm.
Yeah. So anybody get it?
Negative 2.57, which would round to negative 2.58.
So therefore, z star equals to 2 point what?
2.58.
Now give me a little more precision.
So the answer was negative 2.5758. So it would go to
5758.
yeah,
And then what's the number after the 8?
a 2.
So let's leave it like that. Remember, we want to round as little as possible now, but on the ends we could round our final answer.
Okay.
But right now we don't want to round too much, as we saw earlier. The consequences of rounding is that you get the wrong answer.
Yeah.
So anyway, now we can find the margin of error is 2.5758 times, now we're doing with the proportion, so square root of our p hat. Our p hat was 535 over 2016. Okay, 535 over 2016. Copy, come down here. I'm gonna just do this, paste, and then, well, this is kind of gonna be a little bit weird because I'm using the exact number, so I don't have to round. But that's gonna be hard to plug into a calculator.
Oh, I got it. It was a 0.53.
So this, so you got this already, you're saying?
Yeah, I got p hat.
You found sigma sub p hat, or
Yeah.
you found p hat? You saying
P-hat.
you found p hat?
Yeah.
Okay, what did you say p hat was?
P hat is 0.53.
But
But if you want like a not
Yeah.
rounded number, I got 0.52657.
657. So I'm gonna say 66. 5266. 657. So 66, right?
Okay. So you want us to round basically 4 decimals?
4 decimals, at least.
Okay.
At least. As we saw in that one question, we need 5 decimals. 4 decimals. See, now me personally, to tell you the truth, I would plug this in at exactly. I wouldn't even round this at all.
Okay.
But I think you're okay. If you round to 4 decimal places, you should be okay. For instance, check this out. Watch this. You can thank Ernest, the creator of this app, for this. He showed me how to do this. The creator of Graph and Calc 83. His name is Ernest. He created this calculator, this app. It's free. And he told me that he recommended that I tell people to store values. But I don't know if you want to learn that now. But anyways, watch this. If I do this, 535 divided by 1016, I could actually store that into a variable like x and then use x later. You don't have to do this, but it is an option. You can store numbers so that you don't round them. Now I'm not going to round that at all. I'm storing it into x. So watch, I press enter, and now watch, when I press X, guess what it gives me? That number. If I press X, it gives me that number, so I can use X as a variable. So now when I go 2.5758 square root of this fraction, which Ernest also told me about this fraction thing, but then I can do X, 1 minus X divided by 1016. Do you see that?
Yeah.
How you can store a number into a variable? That could be useful if you want to have more accuracy. So now that's enter, and I get that this is equal to approximately what? 0.0403 as my margin of error. Any questions on the margin of error?
Yeah, because I would have to figure out how to store that number into X on my.
Oh yeah, so I'll show you again. Because that's kind of like a nice little trick.
Yeah.
So watch. 535 divided by 1016. And do you see the STO at the bottom? Like right here? To the left of 1.
Oh, yeah.
So if I press store, notice how it puts a little arrow there.
Oh, uh-huh.
And then now just click X, like store it into X. So that's how you store a number with a lot of digits. You can store that whole number into a variable X.
Oh, you're supposed to click alpha store. Yeah, I figured it out.
You got it?
So you do the 535 divided by 1016, and then you do store. So, and then after that, you click alpha, the green button right here.
Okay.
Click alpha, and then you click store again, because that's where X is at. And then you get, oh, you can't see it, but you get X, and it saves.
Okay. You see this calculator? So watch. 535 divided by what?
1016.
So Kimberly already figured that out. But look, I get 535 over 1016. I press store, and then do you have an X up here or no?
Yeah.
So then I just press X. Did you do that or no, Kimberly?
I had to press alpha store to input.
Oh, you're using this X down here?
Yeah.
What about right here next to alpha?
Yeah, that one works.
That one works too. It's the same thing.
Yeah.
Yeah.
I would use that one because that one you don't have to put alpha.
Oh, okay.
Yeah, so then
Yeah,
just press
let's do that.
enter. And now when I press X, press enter, boom, it has that value with all of that precision. You see all that precision?
Yeah.
That's a lot of digits, so then that's very accurate.
Yeah.
Then you do your 2.5758, and then times square root. Now, I don't think you guys have fractions, do you? So then, but watch, you can do this. X, parentheses, 1 minus X divided by what? 1016. Do you see how accurate that is? Because I'm using X.
Yeah.
And then just press enter, right? How do you press enter? Like this? Boom, 0.0403. Pretty cool, huh?
It replaces the X by its, like, once you enter that, like, save the number to X, once you enter X into an equation, it automatically, like, it already knows that X is that number.
As long as you press store, as long as when you get the number, you press store into X. You're storing a number into the X.
And then, like, how many, is it just stored for the next time you press enter on your calculator?
Yes, it's always there. Look, X, still there. See?
And then how do you clear it? So, like, let's say
you don't need to clear it. You don't need, I mean, if you want to clear it, you could clear it, but you don't need to. Why clear it? When you need something new, just store something into it. Like, and you have other variables too. Look, say I have a number like 245 divided by 523, and it's some long decimal. Watch, I can store this into alpha A. I can store it into A. So now when I press alpha A,
it's a different.
Boom. And now I press X, boom. So I can press this, X, A, multiply X times A. So anyways, that's all.
Yeah, that's a good trick.
Yeah, it's a good trick. And then we just helped a bunch of people too with this video when they see this.
Yeah.
All right, y'all, is that good? We did an hour and a half. Is that cool?
Yeah, that's great. Thank you so much.
Thank you so much. I know this is cutting into your very much.
Yeah, it's gonna be a lot of time editing this video, but whatever. Cool. Well, anyways, it was fun. I hope that helps.
It did help. I feel a little better.
You know what you should do? You know what you should do? You should email out like 2 secret questions that are gonna be on the test, and whoever's like, don't say anything, just send an email.
Yeah. Send a really long paragraph that no one's gonna read, and the secret test question there.
I get it, like
So-
Easter eggs, like little hidden secrets. Like if you watch this and you find this, boom.
Yeah.
Basically, yeah, you really should. Just
Ah.
like 2 questions, like the hardest one, so people
Hardest
have
questions. Yeah.
So if they
Hardest
saw it,
ones.
like, if they saw the video, or if they check your emails, they'll do good.
Yeah.
And
Yeah,
you could send it like Sunday night, so then they only have like that span before class.
Yeah,
you know?
right.
At like 12 in the
I would
morning.
That's right.
You should do it.
All right, that's cool. That's funny. All right, well, have a good Saturday.
Thank you.
All right, peace. Take care.
Thank you.
Bye.